Welcome to the group exhibit Hydrogen Fuel Cells and Batteries at the Hanover Fair 2017. We're here at the Technical Forum, and the next 5 presentations will be about fuel cells and their components. So we start today with the Fraunhofer-Institut für Chemische in Technologie, ICT, Angewandte Elektrochemie. Dr. Carsten Cremers is team leader of fuel cells and will talk about electrochemistry-centered services for fuel cells and other electrochemical power sources. My name is Muriel Burkas, and I'm very much looking forward to your presentation. If you have questions, please save them up for later. Your stage is yours. Thanks.
And thank you all for coming to this presentation. I hope I could interest you in further getting into details of the electrochemical power sources that you want to apply in your different appliances. Okay, this is not working. Okay, thank you. So the outline will be that I shortly introduce ourselves, then in one slide discuss why people should care about electrochemistry if they only want to use a fuel cell or battery, then show examples, very established examples, what we are doing already for customers in industry and battery, and what we imagine, what we want to do in future also for our customers in fuel cells. So Fraunhofer-Institut for Chemical Technology is part of the Fraunhofer Society, the largest society for applied research in Europe, with currently 69 institutes and research units, almost 25,000 people staff, and 2.1 billion euro annual research budget, whereof about 3/3 from contractual research. Okay. We are one of these 69 institutes, and something is not working here. Sorry. Okay, it's not working either. So we are doing applied research in 4 business areas. It's energy, environment, chemistry, process engineering, defense, safety, and space and travel, as well as the automotive and transport technology. Next slide, please. Structured in 5 departments, whereof my working group is centered in the Department of Applied Electrochemistry, as already mentioned, working in 4 groups on batteries, on flow batteries, so the very large storage not mentioned here, my group on fuel cells, and as a cross-section activities, sensors and analyzer systems. Next slide, please. So after this very brief introduction about us, why should we care about fuel cells? So many people think if they buy a fuel cell or battery, it's a black box. It delivers current if we supply whatever is needed, hydrogen or current to charge it, and we don't need to take care about the internals. This is true as long as it's used at ambient temperature, like we have it here, under normal conditions. If you stress it in some way, it's better you understand why it's stressing to it. Then you can also know what to do to avoid hazards. It's also sometimes, we have a lot of customers with this problem, that they want to use a fuel cell for an application where it seems to render, but it has some specialties. There's nobody designing a fuel cell for them. So we need to see how to run off-the-shelf fuel cell under these conditions. And especially for the battery colleagues, it's really, if you have to use a battery, you better know, also for liability reason, what is happening if a battery is abused and where you need to take measures to avoid damage to the customers. Therefore, we think it's important also to understand on a certain level the electrochemistry and therefore our services of importance. And in the battery, if this is accepted, I will show some of the services we are commercially offering. Next slide, please. Example given, the electrolyte in the battery. It's very important to know under which conditions, and there can be various, to know if it's destroyed, and if it is destroyed, what is happening under which conditions. And we use a technique called DEMS, differential electrochemical mass spectroscopy, where we can get indeed detailed knowledge for certain battery chemistry when the electrolyte is attacked and what is going to happen. And this really asks for this service, and many people are interested in this. Next slide, please. Also, it seems quite unreasonable, but it's actually like this, that people have problems in simulating battery packs, larger battery packs, because we don't know the heat capacity or the thermal transfer coefficients of their cells. And we have now a service which is really demanded after by industry, that we are measuring exactly these values for the customer and know how to measure heat transfer in a battery cell, in a coined cell, or in a prismatic cell. Next slide, please. The usual thing, safety test, everybody needs to do this. We have, with our experience of the explosive market, we have now the option to do abuse tests on a very large size of batteries. Can do all the required testing. Next slide, please. And we can also do analytics around this. This is the physical analytics. We can really monitor what is the heat release, what is the amount of gases released, which is required by the people to design safely the battery pack. Next slide, please. And what we are really proud of, we have an online analytics, so we can also see what is leaving the cell if it's in abuse. We can tell our customers what is leaving, where we need to be careful, what we need, kind of filters we need to apply. And also this service is very strongly asked for. Colleagues cannot give appointments for this for the next few months. Next slide, please. We would like to offer similar services in the fuel cell, also starting at materials. And we think one of the topics which is really of importance to commercialized fuel cell is the longevity. And there's a lot of accelerated stress that's going on, and trying to discern between the platinum degradation and the carbon support corrosion. And we say with our expertise in DEMS, we can monitor it directly, even under the transit condition. We have in the funded projects shown that we can really discern between different supports, exclude the effect of the platinum, and say very exactly what is the carbon loss rate for a certain time of carbon. Next slide, please. We can do this also on single cells. We have a dedicated setup where we can measure online with mass spectrometry the CO2 leaving. If required, and for certain catalysts, we have discussion with Los Alamos on this topic. If we use the future RN or carbon nitrogen catalyst, there might also be traces of CO as a corrosion indicator. With changing the other gas beside the oxygen in the simulated air to argon, we can also easily detect this, and then can see online what is happening. Next slide, please. We have done this, and an example of the result. This is a test rig here, shown here, and we have shown that the FCCJ stress test is sufficient to detect the carbon supports corrosion, but we have a strong enhancement of the support and only the support corrosion, not of the adjacent MPL corrosion. With the stress test, it's really valuable, and we can show that we have a strong temperature effect, which also depends on the kind of support. And surprisingly, the temperature effect for the CNT catalyst, which at ambient temperature, normally tested in literature, is much more stable, is much stronger, so that we lose part of the advantage of using CNTs there. Next slide, please. Also, a strong topic is what is happening if we have impurities either in the air or in the fuel. We have a test set up now where we can do mass spec at a real gas diffusion electrode. We have developed this for HDPAM. We can do it also at ambient temperature or somewhere in between. And one of the tasks we did here for a particular customer was the question if you have sulfurs and aromatic compounds in there. We injected into the cell hydrogen which was saturated with toluene and thiophene. We could clearly show that we don't have effect on the platinum catalyst by the thiophene at this temperature of 160 degrees. And with a mass spec, we could even show that we are oxidizing the thiophene, that there is no problem there at all. Next slide, please. Also, one of the topics we are working on since quite some time, DMFC, there's always a discussion since ages now. Is it worthwhile to use a tolerant cathode catalyst, or can we deal with the problem of methanol crossover on the system level? And one of the catalysts which was always discussed as potentially methanol tolerant catalyst is platinum cobalt. We have here two different catalysts. On the left-hand side is a platinum, right-hand side platinum cobalt catalyst. And what you clearly see is for the platinum you have this oxidation peak here. But what you also can see is that you have a lot of volatile organic substances released. It's not only the CO2 that you lose in methanol, you also emit formic acid, and most likely also formaldehyde if you try to oxidize it. And it's all gone if you change to something tolerant. So there is an issue there if you want to use it in indoor with a DMFC, that you need to see what is releasing there as volatile organic substances. Therefore, I think the topic of methanol tolerant catalyst should be addressed again. Next slide, please. Coming to the last topic I want to present, where we're working on the special purpose system design. And here we can support customers by developing a system around a standard fuel cell, so something we can buy off the shelf, make the fuel cell work under whatever conditions the customer needs it to work. This comprises that we select the most suitable fuel cell we can find, that we evaluate this commercial available stack, see where it has its weak points for the given application, develop an operation strategy, including hybridization of the battery. We have this expertise in our group, which is then the uptime, how long does it need to run, the durability, how long is the customer expecting the fuel cell system to live, usable fuel and oxidant. This is not always air, because not every customer in his appliance has air available, and then design the balance of plant around it and make a demonstration system. Next slide, please. So here's this work scheme. At a given example, German Navy contacted us and said we would like to see a fuel cell in this small submarine here. So the confinement we had was the space, that it needs to have about the same weight as water, density as the water, the total system. And it needs to operate on pure oxygen. And nobody on the commercial side wanted to sell a hydrogen oxygen cell. So we evaluated what is the best cell we found. We found this one from a small German enterprise in the south of Germany. We tested it for the longevity. Problem is, if you are 100 meters below sea, it's difficult to make a purge, because then you need to operate the whole stack at more than 10 bars in order to get it out. And therefore we tested first, could this stack potentially, if we don't have the air, and therefore no nitrogen crossover to the anode, run for 24 hours, which was a given uptime without purging? In principle it does. We then did a careful calculation, how much volume do we need to provide if we really want to dilute the remainder of nitrogen which comes with both gases into the system, just to avoid that we get into critical state. And we see that we can build smaller if we recycle also the hydrogen. We've made then I can only show the simple system design because the rest is restricted. Made the system design, verified it that it worked, and the demonstrator, which in June will be tested by the Bundeswehr somewhere at the Baltic Sea. So this we can offer if you have a special application where nobody wants to sell you a stack because it's 2 to 3 pieces. We can see that we can get a commercial stack into this. So thank you for your attention. If you have questions, ask them now or come to our booth E65/1. You're welcome to visit us.
Thank you very much for your presentation, Dr. Cremers. questions in the audience? Not so far, okay. So as he said, E65 is a booth. Pass by, have a look, have a chat. Thank you again very much for your presentation.
Thank you.
One more warm applause. So the next presentation will start in about 5 minutes, and it will be from Forschungszentrum Jülich GmbH regarding our SOC plant, efficient design and operation behavior. Please stay with us. I'm looking forward to the next presentation. Thank you.